Welcome, tech enthusiasts, to a journey into the cutting-edge world of serverless computing. In this video, we'll unravel the mysteries, explore the advantages, acknowledge the challenges, and conclude with the undeniable impact of serverless. In the landscape of computing, traditional servers have long been the backbone of applications. These physical servers required constant management and maintenance, making scalability a complex challenge. But what if we told you there's a revolutionary way to build and deploy without managing servers directly? Introduction of serverless computing. Serverless architecture, often referred to as function as a service, FaaS, allows developers to build and run applications without dealing with the intricacies of server management. In this model, functions are the fundamental units of execution, triggered by events. This abstraction of infrastructure complexities is the cornerstone of serverless computing. Imagine a world where you can deploy code in response to events like HTTP requests, changes in data, or even scheduled tasks. Serverless allows for an event-driven paradigm, enabling developers to focus solely on writing functions that execute in response to specific events. Advantages of serverless computing. Now that we've grasped the concept, let's explore why serverless has become the go-to choice for modern applications. The advantages are truly transformative. Scalability is one of the key benefits of serverless computing. Applications can automatically scale based on demand, ensuring optimal performance without over-provisioning resources. This dynamic scalability not only enhances user experience but also leads to significant cost savings, as you only pay for the resources consumed during execution. The cost-effectiveness of serverless extends beyond scaling. Traditional server setups require continuous provisioning and maintenance, incurring costs even during idle periods. With serverless, you only pay for the actual execution time of functions, minimizing costs and maximizing efficiency. Reduced maintenance is another notable advantage. Serverless providers handle infrastructure management, security patches, and updates, allowing developers to focus solely on code development. This shift in responsibility not only streamlines operations but also frees up valuable time for innovation. However, no technology is without its challenges. In the realm of serverless, we encounter considerations like cold starts and limited runtime. Understanding these drawbacks is crucial for a balanced perspective. Cold starts occur when a serverless function is invoked after a period of inactivity. The initial delay in spinning up the required resources can result in increased response times. While serverless providers are continuously optimizing this aspect, it's essential to be aware of its potential impact on certain applications. Another consideration is the limited runtime of serverless functions. Long-running tasks may face constraints imposed by the serverless environment. Developers need to carefully design functions to fit within these runtime limits or consider alternative approaches for handling lengthy processes. Let's ground our discussion with real-world examples. From mobile applications to e-commerce platforms, serverless has made its mark. Witness the versatility of this technology in action. Mobile applications, such as ride-sharing services, leverage serverless computing to handle dynamic loads efficiently. By scaling resources in response to user demand, these apps deliver a seamless experience during peak hours without unnecessary infrastructure costs during quieter times. E-commerce platforms also benefit from serverless architecture. Functions can be triggered in response to user interactions, such as adding items to a shopping cart or processing payments. This event-driven approach ensures a responsive and cost-effective solution for online businesses. As we navigate through the challenges, let's also explore strategies to overcome them. This is where the true power of serverless emerges, adapting and evolving to meet the demands of complex applications. To mitigate the impact of cold starts, consider implementing warm-up strategies. Periodically invoking functions to keep resources active can reduce the latency associated with cold starts, ensuring a more responsive user experience. For tasks exceeding the runtime limits of serverless functions, a hybrid approach may be suitable. Breaking down complex processes into smaller, manageable functions or offloading long-running tasks to other computing models can help overcome these limitations. As we conclude our exploration of serverless computing, it's clear that this revolutionary approach has reshaped the way we build, deploy, and scale applications. From advantages that propel innovation to challenges that inspire solutions, the serverless journey is nothing short of transformative. Thank you for joining us on this insightful journey into the world of serverless computing. If you found this video valuable, don't forget to like, share, and subscribe for more tech insights.